Yeah. Good evening. Good evening to all. So, good evening, Kalyani. So, good evening, Dropalli, Arundhati. Good evening, Manjustri Gowda. So, good evening to all. Welcome back to our channel Pantaki Learning. So, welcome to Masterclass 21-day Masterclass on FPGA design. So, good evening. Good evening, Coding Endless. So, good evening to all. So, good evening, Rekha. So, good evening. Good evening, Ramana Reddy. So, good evening. So, good evening, Karthik Silvaraj. So, good evening to all. Thank you for joining Masterclass. So, hi. Yeah, okay. You will get the registration link. So, our organization will post the link in mid of the masterclass class session. So, just listen the class or just wait in the class. So, you will get the link. So, good evening, Priyadarshini. So, good evening, Pallavi. Good evening. So, thank you for joining to all. So, today is day 5. Today we are gonna see introduction about Verilog HDL. So, this is a hardware description language. So, we can write the hardware functionality by this language by using Verilog. So, there is also HDL language like Verilog, VHDL, and also system Verilog is there to write the HDL. So basically nowadays most of the companies are using system Verilog to write the design code or RTL code. Why? Because of in system Verilog there is a added feature like a logic keyword, so logic data types. So it having lot of features and also it having the OOPS concept. So that's why some most of industry people's like if you taken any Qualcomm Intel, so they are writing the RTL code in the system Verilog only. So and also if you take any government related companies like ISRO or any defense companies, defense IC related companies, they are used to write the RTL code in VHDL. So VHDL is they are using VHDL because of it is safety. So for the safety precautions they are using the VHDL RTL code in the defense side, in the defense field or aerospace field. So and so on. So good evening to all. Thank you for joining. So good evening Sai. Good evening Sushmita. So good evening Monica. Good evening Tamsi. So good evening to all. Welcome to masterclass. So today's day 5. So today we are gonna see Verilog, intro of Verilog and some basic syntax. So today we'll do like try to write a Verilog code for mux and any logical circuits. So we'll write the 2x1 4x1 mux in Verilog. So and then we will see the data types also. So before going to that I just want to ask some like interview kind of questions. So if you guys, I hope if you guys are know about flip-flops like a sequential circuits. So which software defines RTL? So basically they are doing they're making some chip means they are using the VHDL language. So VHDL they will write the RTL like a design code in by using the VHDL. So if using the Verilog means it is easy to understand anyone. So if you know C means you can easily understand the Verilog language, system Verilog coding. But if you see the VHDL little bit you feel difficult to understand. So there is some the VHDL having some separate syntax like architecture entity like that. So for the safety this gives the safety for the code. So that they are using VHDL. So there is no separate software for VHDL. So we can run VHDL code in Intel Cortex Prime and Xilinx so Vivado. So we can use that for the FPGA FPGA development. So my question is, I ask it to you. I hope you know about flip flops in the sequential circuits. So if you know means just answer for this. So what is the condition for the, so what is the functionalities if condition if t equal to 0 and if t equal to 1. So it is a t means it's a input of flip flop. So basically t flip flop is used for, it's known as toggling flip flop. So every passage of clock it will toggle, like it will changing 0 to 1, 1 to 2, sorry 1 to 0. So if they are changing of the, this toggling it happens at the every passage of clock. So there is a condition if a t is input. So t is input, if it's 0 means it will do something, if it is 1 means it will do something. So if you guys are know means, if you guys are know, so just try to answer in chat box, or else I will say the answer. So this is also some basic uh, knowledge about flip flops. So the I will, can anyone, so someone coding endless sayings t flip flop like a XOR gate. So I just want to, just I'm asking what it if a t equal to 0, what t flip flop will do. If t equal to 1, so what t flip flop will do. So basically if the t flip flop, if t equals 0, input is 0 means the condition, if t equals 0 means it won't, it will give same input value. So there is a two input t and d in, so input, and then if it t equals 0 it will give the same value as the output. If you give, if you example, if you give like a t equals 0, so input is 1, so you will receive the 1 as output. Other if you do like a, if you do like a t equal to 1, your input is 0, so it will toggle. So if t equal to high, if t is high means it will toggle the output. So whatever it giving the input, it will give the opposite of the input. So this is a functionality of t flip flop. So yeah, same like a q equal to 1, so it will toggling, so it will toggle based on that condition. Like what condition means, if only that t equal to 1 means, so t equal 1 means it will toggle. If it t equal give 0 means it will give the same output. So whatever it stored in the flip flop, it will give the same output as the t flip flop output. So this is the question, so just try. So and then in the end of the session we will write some 2x1 marks design code, and also you can write yourself by using this condition. So t flip flop, try to write code in Verilog and at the end of the session at your yourself. So let's get into intro of HTL and data types. Yeah, Karthi should is correct. To state changes, so state change means it will toggle, so it will give the opposite of the input value. The main thing is if it is t equals 0, there is no state, there is a state change, but there is no change in output. If it is t equal to 1 means it will toggle the output. So and then we'll move to the session. So before going to that, you must know about some basic knowledge of Verilog. So Verilog is a case sensitive language. So it having the void space, commands, operators, number specification, strings, identifiers, and keywords. So these are the things it I have. Sorry, just a minute. So firstly, commands. So commands is also we use it for our taking. So we have to use it for giving some notes about our code. So if you're writing, you have to mention like this code is this part, like this is a sequential part, this is a combinational part, so this is a register, this is the counter part, like this, like that we have to mention. Then only other person can easily understand. For that you can use the commands. So there are two types of commands is there in Verilog, like a single line command, multi-line command. So single line command means if you want to command single line like this, so a single one line, you just use two double forward slash. So if you want to multiple command means you have to follow this forward slash star and then end of the line or end of the paragraph you must follow this like a star and forward slash. So this is the way of commenting single line and multiple line. So this is a basic commenting operation in Verilog. So double forward slash means single line. So if you want to command multiple of lines means like you have to do like this, like a forward slash star and the end of the line star forward slash. So this is the way, and then you can't do this way like inside the slash forward inside the multi-line command. You don't need to add any other additional commands lines like these operations. It is illegal. If you do means it will throw an error. So our simulator will throw an error. So do like follow these two rules only. So and then operators, so it having the three types of operator like a unary operator, binary operator, ternary operator, like other language like a C and C++. So it also having the that. So you can see the unary operator, it have only the this minus symbol. So this is a unary operator, example for unary operator. So and then this is example for the binary operator. It having the double ampersand symbol. It do the logical and. So you can see if you do some B and if this is the and symbol, so you know that. So this is and symbol B and C. It means it do if you do like if you write A equal to B and C means it will do bitwise and. If you do the B and C, so A equal to B and C means it will do the logical AND operations. So logical AND operations means it will compare both the B and C operands logical values. So this is the difference between bitwise and logical AND. So this is a ternary operator. This is a special operator we have in Verilog. So we'll see in the while writing the code. So it's just like if else. So if you know the if loop, say if statement like if it having some condition, if it is true means it will execute this. So it will execute consecutive line of the what we return. Same like this, it having also I'm assigning some value to A. So the condition is if B if here we can write some condition like if B equal to A, if B equal to 1. So we can write some condition. If B is high means, so if B is true means it will choose C, and then if it is B is 0 or false means it will choose D. So this is operation of ternary operator. So we can see in the while writing the code, is still easy to understand. So let's move on to number specification. So we have the two types of number specifications. They are sized and unsized. So if you have so generally in other language like a C, we can write directly A equal 10, B equal 20, 30 like that. And we can also like A equal to 101, we can write like that in binary for in C, any other language. But here we can write like if you write a binary values, if you want to assign a variable for binary values, so we can give some restriction. So we can give some size of the how many bits of it having. So like this. So you can see here. So this is a syntax for number specification, sized and unsized. So size here this simply is a tick, and then base format means it you can give like a binary hexadecimal, the decimal like that, and then number what we give, you want to give, you just want to write here. So this example for the number specification in sized. So sized, so here you can see 4 means size. So if I write A equal to 4, A equal to 4 tick, this symbol is known as tick, A tick of binary of 1111. So that A that particular A variable it having the 4 binary ones 1111. So this is the way of writing the sized binary inputs for particular variable. So you can write also A equal to 12 tick hexadecimal ABC. So if you use hexadecimal base format, you can use 0 to F. If you use decimal means you can write 0 to 9 way. So whatever you want to. Here it is a 16-bit decimal 16-bit decimal format of 2 to 5. So these are the sorry. Okay, let's continue. So these are the number specification in Verilog. So we can use size for the number bits in the Verilog. So let's move to the unsized numbers. So here you can see if you don't give the size of the number, like here I'm giving the 4, but here I didn't give any number, so it means unsized. So unsized in nature. And also Verilog having the another values like x and 0. So x means unknown value, it may be either 0 or 1. So z means, sorry, x and z, so x means a unknown value, it may be either 0 or 1. And z means it is an high impedance, so high impedance value. So and then here you can see 12 bit of hexadecimal 13x. So we can also assign assign the x unknown value for the particular variable. If you write like in a code a equal to 12 bit of x, 12 tick of x 13x, so it means it having the 13x, so in the hexadecimal format. So like this we can assign the whatever you want to value, like in a format like a decimal, hexadecimal, binary, you can assign for the particular variable. So and let's move to identifier and the keywords. So if you take this variable like output and output r, so output is a keyword, r is identifier. So this is the basic thing. So output is a keyword and r, so r is a one identifier. So and then coming to the data types, so this is important thing you have to know about Verilog. So we having the two main two data types like reg and wire. So like a register data type and then net data types. So net data types nothing but wire. So there is a data type like a wire, and then register data type is we can write as reg. We can write a net data type like wire, like a wire. So basically register data type, it will store the values, and net data types it will don't store the values, it just pass the values to other logic gates in our circuits, like in our logic circuits. So this is the process of the two data types in the Verilog. We have like net data types and register data types. So and then we'll move to this is the values we have in Verilog. We have the in Verilog we have the four values like a 0 1 0 1 x and z. So we know that x means unknown values between the 0 and 1 only, from the 0 and 1 only. So it may be 0 or 1, it won't be z. But if there is another one like a z, it is an high impedance floating stage, so it having some high impedance value. So and also it having some floating state values like is it. So this is a thing. So we having these types of values in Verilog. So this is the net data type keywords. So net having a lot of types like a wire, try, supply 1, supply 0, wire or try, or wire and try. And so these are the data types, like types of data types in the net data types. Mostly we use only wire. So wire is the one mostly used to for connecting the logic gates. So we can use only if you want to use net data type, you can use only wire. So w and w or try and mostly we won't use that. So and then there is something like a try 0, try 1 are not are they are non-synthesizable. So it means non-synthesizable means if you simulate that code, you can't make a logical logic diagram. So we know that synthesize means converting the RTL code into logic blocks. So if you use try 0 or try 1 in your code, you can't make the synthesizable logic gates, so synthesizable circuits. So we can't, so we don't have to use that try 0 or try 1 in our code. So why? Because of this is non-synthesizable, we can't make the logic circuit from the RTL code by if using the try 0 or try 1. So we'll move to so these are the remaining data types like integer. This integer is a signed 32-bit integer variable. So and then real, these are the default value of the data types, like default value of the integer is 32-bit integer variable, real having 64-bit, reg as unsigned. So unsigned, it is using for storing the 1 bit only. So reg, if you use the reg, so only use the if you use reg only, you can store only 1 bit of the particular variable. And then time, so you can is unsized, so unsigned 64-bit integer value, so it having the default value like a 64-bit integer value. So and then the real time, it's useful for storing the time like a floating point value, so you can use floating like a decimal value we can store in the real time. So these are the remaining data types we have in Verilog, like integer, real, reg, time, real time. So and then move to arrays. So arrays are allowed in Verilog for reg, integer, time, and vector. So these are the data types we can use for make a array in Verilog, like a reg, integer, time, and vector register data types. So and arrays are not allowed for real variables, so we can't make a array by using the real data types. So because of it having the some decimal values, so point it having some decimal and the fractional values, so we can't make array from the by using the real real data type. So and then we'll move to the multi-dimensional array. So we can't make a multi-dimensional array in the Verilog, but we can do in the system Verilog. So we can do into a multi-dimensional array in Verilog. And so this is a syntax for that. So data type, variable name, start index, end index. Let's see how it is look like. So this is the array formation in Verilog. Basically, so firstly we have to write in data type like reg, integer, time, wire, whatever you want to. These are the data types we can write the array in Verilog. This is only allowed to write the array in Verilog. So integer, reg, time, so reg and wire. So these are the data types. So you can see a reg, it's a data type, and then count is a variable name. So this is a vector like a 0 down to 7. It means it having the 8 memory locations, like we can store the 8 integer values, so 8 count values, so count variables. So and then reg bool, this is a data type name, this is a variable name. So it having the 31 down to 0. It means it having the, you can store it having the 32 memory location, and each and every memory location you can store 1 bit of data. So 32 1 bit boolean register variable. So same like the time, you can store time checkpoint variable, so you can store it having the 100 memory location from 1 to 100. So you can store the time values inside this array. So and then reg, so it having the, you can see this is a 2-dimensional array like that. So this is a like a data type, this is a variable name, so it refers to width of width, it refers to width, it refers to depth. So it having the, so sorry, it is 0 down to 0. It means it having the like a 7 memory location, 8 memory location. Each memory location we can store 5 bit of data. So 5 bit of data means we can store 5 bit of values in this method, so in this declaration of array. And then you can see wire 7 down to 0, this is a array name. 5 down to 0, it means it having the 6 memory locations. So 5 down to 0 means 6 memory location. in each memory location we can store up to 8 bits. So it having the 8 bit wide, so and it having the 6 memory location. For this is refers to memory location like this, like a vertical. So and then it having in each memory location we can store 8 bit of data, so 8 bit of values. So this is the example for the arrays. So you can see, if you write like a reg 720, it means it having the 8 bit memory, 8 bit memory. So if using like this reg mem 0 down to 0, sorry 0 down to 7, it means it having the 8 memory location, like this one memory location, second memory location, third memory location, like this. So it having the 8 memory locations. So you can see it is a memory of the one. So we can see 0 down to 0, this is a register data type. So this is a variable name, so array name. So 0 down to 1023, so it having like this. So it having from 0 to 1023 locations. And if you are using like this, so reg 3 down to 0, mem of 0 down to 255, so 255, it means it having the 0 to 255 memory locations, and each memory location we can store 4 bit of data. So it having 0 down to 255, it means it having the totally 256 memory location, like this. It having 255 memory location like this. And reg 3 down to 0, it means in every memory location you can store up to 4 bits. So 3 down to 0 means 4 bits, so we can store 4 bit of at every memory location. So this is the way of creating memory, so using array in Verilog. So we'll see in the upcoming sessions. So and then parameter. So parameter is one type of feature in Verilog. So we can, the syntax is parameter name and value. So we can write parameter is a key, we can say like a parameter is a keyword, and the parameter having the parameter name. So we can assign value for that name. If you are using some value, some name like a values for some special character, if you are using some value like if you in your code you are using like a, if you are using in your code a, mostly you are using a for some assigning 5 values. So on that time if using 5 in your code mostly, so if you want to change the value 5 to 6 means you have to write as change all lines of code, like where it is having 5 you have to change for 6. So there is a need to take time to change, like every time you go for find line by line 5, if there is a 5 you have to change to 6. So this is very hard task to change values. For the condition you can use parameter. So parameter, it having the syntax like a parameter name, so and then it having some value. So we can, so instead of using 5 you can use some parameter name. So it, that particular name it having some values like a 5. If I assign the parameter name equal to 5 means that name it having 5. Like if you want to change means you can change by here itself only, you don't need to change all lines of code. So this is the main thing. Using this is a feature of a parameter, you won't need to change all line of code, you just change here in parameter declaration only. So we can also instantiate the parameter in modules. So let's see how it happens in upcoming classes. So let's move to the syntax. So this is the syntax for the Verilog. So it starts from module, ends with end module. So module, end module, it having some module name. So this is the module name, we have to write here module name, and it having the port list. So port list nothing but we know that input output signals we have to declare here. So and then in between the module and module we have to write our logic. So we can now we will see. So in this session I will directly go with the behavioral model style of writing in Verilog. So there is other model style like structural data flow. So there is other styles like in Verilog, but mostly mostly industries using behavioral style to write the design. So it is very important to learn, so that for that only I am directly going to write behavioral style writing Verilog code. So let's see. So this is for if you guys are really interested, so you can convert this masterclass into 1 month masterclass into 1 month internship. So internship on FPGA design. So and then these are the benefits you will get at the 1 month internship program. So you will get the all 30 days recording session, you will get the all 30 days presentation, and you will get the exclusive project codes you can download also, and you will get the community group for your doubt clearing and internship updates. So and you will get the 90 days LMS course access. So and you will get also assignments, tasks to build your knowledge from the internship, and you will get the weekly live sessions for your doubt clearing, and we will you will get some idea about resume building, mock test, and and you will get also internship certificate. So and you will get a participation certificate. These all benefits you will get at if you these all benefits you will get from the internship. So these are the benefits you will get at the discounted fee of just 999. So this is our regular fee 3999. In this masterclass session period, so we are providing our internship program as to the discounted fee of just 999. If you want to this, if you really like this in masterclass, you can join our internship program. So we'll get the detailed recording session of classes. So if you want means you can using this link, this registration link, you can get the internship. So and also our organization will post the link on chat box. So this is a limited time period offer, you can get it. So let's go to Verilog code writing. So this is this is the 2x1 mux. It having the two inputs I0 and I1. Based on the selection line, you will get the output like if selection line equal to 0 means it will choose this line. So it will choose first input as the output. So if selection line is 1 means it will choose this. So if the based on the selection line condition, if it is equal to 0, it will choose this, it will select this line. So first line means first input. So you will get a output of I0, whatever it having value you will get as output. So if you select s equal to 1, it will select this line. So you will get the I1 as the output. So whatever it having some values like a 1 or 0, you will get the output in Y. So if you select the second line like a first line, 0 line, so 1 line. So this is the condition. If based on the selection line, I will choose the inputs to get the output. So I will choose the select lines. So this is the basic 2x1 mux. So I just going to write RTL code for this. So Verilog code for this. So I'm going to use EDA playground. So that only by using this EDA playground I can easily simulate by using here tool. I selected the Siemens Gustav simulator for simulation. So and then I just go to write the code. So firstly we have to write module name. Module name is and there is one important thing. If you write the module name, we have to start with the character. So like alphabetic character, you won't start with the number, so it will throw an error. So I just write mux underscore 2x1. This is my module name. So in module. So inside the bracket I have to write the my port list. So port list is nothing but input and output signals of our design. So this is my design. So on 2x1 mux. So inputs are selection line and I0 I1. So I just write input I0 and I1 and cell. So here each and every input signals it must contain only one bit wide. It means it is either 0 or 1, and also I0 I1 it may be 0 or 1. Just for that only I didn't use any array like a vector form, so that, and then I'm writing output y. So I'm going to and then I'm going to write a always block. So always at, inside that I'm just write so this is my syntax of my RTL code. Module and module, this is a basic thing, basic syntax. Module name, port list and end module, this is a syntax. So inside that we can write a logic by using the always block. So always block, it is the one block in Verilog. So it works like a if condition only, so if statement only. So it will always means, here you can see at, I give some at, inside the bracket I put star. It means it is checking the triggering element. So if I write here cell, it means I'm always checking if my selection signal it is triggered, means I will execute this. So I'm like always block. So I'm saying, imagine I'm the always block. I do actions, I do always block execution. Like if my selection is triggered only, I can execute my always block. So this is the function. So always block waiting for selection line. If it is triggered, it will execute the always block. Whatever written inside the always block, it will execute. So this is the function of always block. So yeah, instead of if you using the sequence circuits like a flip-flop, you must need clock as an input. So as the for that time you just need to write a clock as at the passage of clock, at the neckage of clock. We'll see in the upcoming session. So but if I'm here, I'm going to use star. It means it will this always block will see all the signals in my port list. If I0 triggered, or if I1 are triggered or not, if cell are triggered or not, and Y are triggered or not. If any one of signal will, if any one of signal is triggered, it will execute the always block. So it is always checking my port list, my all signals in my port list. If any one of signal is triggered, it will execute the always block. So this is the function of always block. So and then we write the ternary operator. So we know the ternary operator like a equal to if b, check if b, you see in the starting of class like this. So this is a ternary operator. So I'm just following that the same way. So I want to get output as y equal to, I'm checking cell. So I'm checking if cell, this means I'm checking I want y output. So I'm checking cell. If selection is if selection line equal to 0, it will choose first input. So it will choose this line. So it will select the this input. So if selection line is 0 means, so just write if selection line, if equal to equal to, it means logical equal. If it is 0 means I will get output of I0. So other if it is 1 means I will get output in I1 value. So this is the logic of 2 cross 1 mux, the equation by using the ternary operator. So I'm writing. So if this is a selection line, s equal to 0, it will select the first input. If s equal to 1, it will select this input. So same thing I'm writing in the Verilog. If cell line equal to 0, I will get this input as output, like whatever it having value I will get as output. So if it is 1 means I will choose the second line. So this is second line. So this is a writing of 2 cross 1 Verilog code. So this is easy only. So and then I will show you count to command multiple line. So I'm just using star here, and then in here I'm using, we can see we can write another remaining code you can write after this. So this is a multi-line command, though this is a single line command. So this is a design code. So and then we will move to test bench code. So we written our design code, we have to write our test bench code. For that same we have to write a module name as test tb, and then end module. So this is a response syntax. Here we have to write a register and wire. So we know, so in this test, while writing the test bench, input signals are you must write as in the reg form, like I0 and then I1 and then cell. So these are my inputs, so I can write in the test bench as a reg form. So it will store some values. Basically the signals storing some values, so that for that only I am writing in the reg by using the reg data type keyword, data type I am writing that. So and then wire, why I am using wire means, so I will get the output here wire, so just use wire here for the output. So for if you use while writing the test bench, inputs are you must write in reg data type, outputs are in form of wire data type. So this is a rule. And then we have to do instantiation. So instantiation is nothing but instance. So instantiation is nothing but connecting the design code and test bench code. So this is our design code. We have to give some inputs. So we have to give inputs for these signals. For that we are writing test bench. So we have to connect these two modules. For that we have to write an instantiation. This is how means, just you have to write a design module name. So mux. So mux underscore 2x1. This is 2x1. This is my module design module name. So I just write here, and then instance name. So I just write any name. So like a instance name is A1. You have to open and close bracket. Inside that you have to connect by signals. So like a connect by you have to connect the signals by using the this way I0. So you can see this means dot of I0. I just put over here. So you can see I0, this I0 inside our bracket we have I0, it refers to our current module signal, and then this I0 is refers to design core module. So I am just connecting that test bench signal and design core signal by using this way. So you have to follow this way. So and then I1, so and then cell, so and then output y. So this is the instantiation, we done it. So before that you have to give dot here, so dot. So and then initial begin block. So this is our simulation runtime block, initial begin. So this is from this block only our simulation will start. So I'm just writing some printing statement like a dollar monitor to see my outputs. So it will dollar monitor works like a always block only. If any of the signals triggered, it will automatically monitor that and displaying in our output, just like always block only. For that I want to see time in the decimal format, so just follow this way. And then I want to see inputs are I0, what is I0 input in the binary form, and then I1 I want to see in the binary form. So and then cell I want to see in the binary form. So and then Y, so in the binary form. So these are the signals I want to see in my output. So I just use $time. So this is a one keyword to see the output in time, so to see the time, so execution simulation time. So if you want to see the simulation time, you can use $time in your display statement. And then I0, I1, and then cell, and then Y. So this is the signals I want to see in my output. So I just completed my display statement. So and I'll move to so you have to give semicolon for to close the line. So this is also basic thing. So I just give some delay. So it means I'm using the as 10. It means I'm adding delay in simulation. So it works based on our time scale. So we have time scale like 1 nanosecond by 1 nanosecond. So it will works in the nanosecond. So after 10 nanosecond I am passing some stimulus for my signals. So I'm passing some signals like a stimulus to my signals, like I equal to I0 equal to 1, input to 0 equal to 1, and then input 1 equal to 1. So I'm changing like a 1, input 1 equal to 0. This is my inputs. And then after some time, after some 10 nanosecond, I just saying like a selection line, cell equal to 1 bit binary 1. So I will select the second line, like I will select this line. So I will if cell equal to 1 means it will choose this line. So let's see what I'm getting in output. So this is my design code. I'm just selecting the this line. So first line, 0 line, first line. So I have to get the whatever it having I1 value, I have to get in my output. So I just run this, save and run. So I get some error here. So if you're using the always block, here I'm using the Y inside my always block. I would write here reg store to store the values. Why? Because of if I use assign statements, I can write without reg. If I using always statements, this is a condition. If you use any variable inside your always block as your output, you have to write reg keyword in front of your variable. So just run this. So I just mistake print binary. So here yeah, you can see here output. So this is my starting stage. At the starting stage of my simulation, I have the unknown values. and then after 10 nanoseconds I given input like I0 equal to 1. You see in this code like I0 equal to 1, I1 equal to 0. So I0 equal to 1, I0 equal to 1, I1 equal to 0. So at the time I didn't give any selection values, selection signal. So for that, so that why I am getting X here. And after 10 nanoseconds you can see, after 10 nanoseconds I give cell equal to 1. So I will choose the first line. So this means it will choose this. Cell equal to 1 means it will choose I1 as output. So I will get the I1 value as output. So you can see 0 here. I am getting the 0 output. What it having the I1. So if I change I1 equal to, one, I just save this. So I just save this, I run this. Let's see what happen if I'm getting 1 or not. So it's getting late, already 6:50. So just try to close. So you can see here I1 equal to 1, my cell equal to 1. So it will choose this line. I will get the 1 as output. So this is a logic of writing the 2x1 mux. So we have tried for, if you want to, you have tried for design code. For verification you have tried for test bench code. For simple 2x1 mux. So this is a thing in Verilog. You have to write a lot of code in Verilog to verify and design this, to design the code. If you take in Python or if you can write, you can simply get output like easily. We can it will easy to write and you will get easily. It need less number of lines to write the logic. But in Verilog and system Verilog we have to write more lines. So we have to write 2 codes like module and module. So this is for today. And then I'm just writing 4x1 mux suits, or else you can do 4x1 mux. So I'm just fastly writing 4x1 mux for your clarification, for your understanding well in Verilog. So 4x1 mux inputs are I and the selection lines, Y is output. So I'm using vector form. So input 3 down to 0 of I in. So I'm using vector like a 3 down to 0. It means it having the 0, 1, 2, 3, totally 4 inputs. It having the 4 inputs like this 0, 1, 2, 3. So and then it having the input, another input like a 1 down to 0 selection line. Y means here for 4x1 multiplexer you just need to 2 bit of selection lines. Then only you can select the input lines, 4 lines. It's like a 2 power 4 or 2 power n combinations. So 2 power n means 4, 2 to 4. So totally 4 inputs. So for that you for n equal to 2, so you need 2 selection lines. If you have the 2 power 3 like 8, if you have 8 bit means 8 bit of input means 8 lines of input means you just need to you just need 3 selection lines. Then only you can make 8x1 mux. So this is the 4x1. For that we need 2 selection lines. So I just write 1 down to 0. It means 0 0 1 0 1 1 0 1 like that. So and then I have only 1 bit output. So you can see 1 bit as output. So I just write output reg y is my output. So I just close the bracket. This is my port list, and then I am using the always block, always block at trigger. I'm just using that star to trigger all the signals in my design, begin, end. So and then I'm writing the condition for the 4x1 mux. I just rename my module name mux underscore 4x1. So I'm going to use case cell based on my case only I will get. So I'm based on my case, I am using the case logic to write the 4 class 1. So if 2 bit of, if the cell is 2 bit of binary 0 0, like a 0 0, if the selection line is 0 0, it will choose the first line. So I will get the output I1 line. So y equal to I0. So like in inside the bracket 0. So this is the condition that for that. So and then here you can see inside the square bracket I am using this value like a 0. It means we having the vector form of input in. So in, so it having the 4 bit, so it having the 4 like a 4 values. So I'm assigning the first value like a 0th value for the cell 0 0, like a cell equal to 0 0 means. So I'm just, and then I'm writing the 0 1. If my selection line is 0 1 means it will choose this first line, so I1 as my output. So I just write 1 here, and then P1 0, and then y equal to in of 2, and then take binary 1 1, y equal to in of 3. So I'm just writing some condition based on my 2 cross max functionality. So and then I write some default condition. I will say my default y, I will say default y as unknown. So I just write 1 bit of binary x. It means I'm saying if there is no condition for selection, my default value is, I'm saying my output like a default value having the x only. So this is the condition, and then end case. So this is the always block. So for the 4 plus 1 marks. So this is the design code we written for 4 plus 1. So I'm just so there is another way to I'm just writing the response code. So reg of 3 down to 0, 3 down to 0 of in, and this is one, like, and then reg of 1 down to 0, 1 down to 0 of cell, and then wire is a output, so just y here. So in the instantiation I just do some shortcut trick. So this is one feature in here. So what is that means, we just give just star dot star. It means it will automatically port by name of it will automatically connect to this design code by name. So port by name, so sorry, call by name. So and then I'm just changing my here some signals. in I want to see in my binary, so I just do binary, and here also change in. So I just pass the stimulus. So firstly I'm just I'm saying my inputs values are I in, so in input equal to 4 bit of binary 1 0 1 1 1. So this is my 4 bit. So I already said no, this is a sized assigning. So sized value assigning for input. if I select the first line means, if I select the 0th line, I will get a 1 as this one as output. 1 means I will select the first select line slash sorry, it means this is a 0th select line, first select line, second select line, third select line. If I choose this means I will get 1. If I choose this line means I will get 1 as output. If I choose this means I will get 0 as output. So let's see how it works. So after some 10 nanosecond, I just pass my selection equal to 2-bit binary of I want to see the 0 as output. For that I just write 3 means sorry 2 1 0. Let's see what happens. There is one error, dispense 15. So I just must to be here binary. So I just run this. Then you can see here output. So initially we having the unknown values, and then I assign some input value for I in, so 1011. So you can see my selection line is 10, so third line. So in the third line you can see this is my input. So in the third line is 0, so I'm getting the 0 as output. Y, you can see y equals 0. So on same time I will write for cell equal to, so I just copy this and then paste here. So I'm just changing my selection as 0 0 0 1 and then 1 0 1 1. So let's see what happens. So I will see all the 4 display statements for output. So I just need to give delay here. So I just must here delay 10 here, then 10 here, 10 here. 10 means 10 nanosecond. Yeah, you can see here, if my selection line is 0 0, like it will choose this line 1 0 1, it will choose this line, I will get as 1. It will 1 0, it will choose third line, so third line is it having 0, so I will get a 0 output. 1 1, so it will choose fourth line, this one, it having the 1 value, so I will get the 1 output. So we return the 4x1 mux logic in Verilog. So it is very easy only. If you know digital electronics concept or circuit very well, you can easily write the Verilog design, and you can also verify. So it is also writing test bench is also very simple. You must need to write instantiation and initial begin and pass some stimulus to design code, so like this. So this is the way of writing Verilog code. So this is for today. So we'll see tomorrow, guys. So thank you for listening. Thank you for your response. So thank you, guys, thank you for listening. We'll see tomorrow with some other combinational code and the sequential code. So tomorrow we will have with the theory part and also demo part, like RTL coding part. So we will write coding and also we will do theory part tomorrow. So thank you, guys, thank you for listening. Thank you.